Today we're going to start exponential and logarithmic functions. We are going to start with the algebraic portion of these notes, which is the backside. So today we are going to learn the basic log property and how to transform in between a logarithm and an exponential function in order to be able to solve them. We're also going to go over the three properties of logarithms. We are going to be covering the graphing portion, the first page of this notes, tomorrow. So if I look at these functions, you'll notice I have a little picture here. I call him my hamburger helper hand. And that is what we're going to use to convert. So to convert exponential or logarithms into exponential functions, I'm going to draw a hamburger helper hand. I'm going to start at B, and I'm going to draw my three fingers. Notice every time I go down, that's the next thing I'm going to write. So this becomes B raised to the x equals y. So I started here with B, and then I went to the x equals y. That's how we are going to convert. So if I look over here at my examples, if I want to convert this first one, 2 raised to the third equals 8. 2 raised to the third equals 8. So one thing I want you to remember is that the answer to a logarithm is an exponent. That's basically what we are figuring out. Is 2 raised to what power gets me 8? I can also use the hand backwards. So it's going to be 5, 625 equals 4. So what we do is we start with the word log. The 5 becomes the base. 625 equals 4. Please, today while you're doing these, draw the hands. It will help you. Every time I drew a finger down, meant I needed to write that next. We have two important notes that we need to talk about. 10 raised to the x and log x, so log with no base, are inverses of each other. Okay, if you do not have a base there, it is understood to be 10. And that is because we are in a base 10 number system. The other one that is inverses of each other, and we're not going to cover this semester, but we will get to it next semester, is e to the x and ln x. Okay. ln is natural log. You do notice on your calculator there is a log button and an ln button. We are going to use those this semester. Not today, but we will be using them. So next we have 3 laws we need to write down. The first one is log base b of x plus log base b of y equals log base b of x times y. Okay, and we can bring this back to when we had exponents. Do you remember when I had 3 squared times 3 to the 5th? Well, I figured that out. I added the exponents, and I got 3 to the 7th. That's the same concept we're doing with logs. Since they're inverses of each other, they have the same sort of properties. The next one, so I have log base b of x minus log base b of y. That is going to be log base b of x divided by y. And that would be something like when we had 7 to the 6th over 7 to the 4th. Well, to figure that out, I kept the 7 and subtracted 6 minus 4 to get 7 squared. The third one doesn't have a corresponding exponent property. So it is log base b of x raised to the p. And what I'm going to do is I'm going to take this power and I'm going to move it out front. So this becomes p times log base b of x. So when I have an exponent, I can actually move that out front, which will make some of our simplifying easier. So where are we going with this? We want to use these laws and these rules to help us evaluate logarithms. And we want to do it without using our calculator. So let's try some examples. So here we go. First things first, we're going to draw our hand. 3 raised to the x equals 9. The only way to really solve a logarithm is to convert it to exponential, because we can solve exponentials. We're good at that. We understand how those work. So this was 3 raised to the x power equals 9. So I asked myself, well, 3 raised to what power gets me 9? So I can rewrite 9 as 3 squared. If the bases are equal, my exponents have to be equal. So x equals 2. Now where I eventually want you to get is that you can look at it and tell me that answer is 2. Because what I'm asking myself in my head is 3 raised to what power gets me 9? That's what I'm trying to figure out. So for letter B, first things first, I'm going to set equal to x. So what I'm asking myself, 4 raised to what power gets me 8? Well, this one I'm not too sure, so let's go ahead and do it, write it out. So I draw my little hand. 4 raised to what power gets me 8? I can't rewrite 8 as 4 to some power. 4 to the first is 4. 4 squared is 16. That doesn't work. So I asked myself, is there a common base? Can I rewrite both of them using the same base? And I can. 4 is really 2 squared, and the x comes along. 8 is really 2 to the third. So since my bases are equal, my exponents need to be equal. So x equals 3 halves. Okay, on to C. Again, step 1, set equal to x. Step 2, draw your hand. Step 3, write it out. 2 to the x equals 1 over 16. So first thing I want to do is get a common base. 2 is the smallest base. There is no other base I can use. So how can I rewrite 16? So 16 is really 2 to the 4th. Now, how can I move it from the denominator to the numerator? Remember, to do that, all I need to do is change the sign of the exponent. So this becomes 2 to the x equals 2 to the negative 4th. To move a position, I change the sign of the exponent. So making it negative will bring it up to the top. Now my bases are equal, so my exponent is x equals negative 4. Next, let's look at D. Again, step 1, set equal to x. Step 2, draw the hand. Step 3, write it out. 8 to the x equals the square root of 1/2. So my common base is going to be 2. So this becomes 2 to the 3rd, and the x comes along. 1/2, so this has an understood exponent of 1. To make it, move it up to the numerator, I'm going to make it negative, so that means the square root of 2 to the negative 1. But I still need to do something with that 1/2. The square root. Remember, square root is the same as raising something to the 1/2 power. So this becomes 2 to the 3x equals 2 to the negative 1, all raised to the 1/2. So if it was cube root, it would be raised to the 1/3. Fourth root, 1/4. And now I set our exponents equal to each other. So it's 3x equals negative 1 times 1/2, because that's what I do with my exponents. Remember, when we raise a power to a power, we multiply the exponents. So that gets me 3x equals negative 1/2. And now I'm going to divide by 3 or multiply by 1/3. So x equals negative 1/6. So if I look at E, so here my x is in another position. That's okay, we're still going to do the hamburger helper hand. So x to the 1/3 power equals 5. Well, really, remember, 1/3 power, I could really write that as the cubed root of x. And how do we undo a cube root? We raise it to the 3rd power. So we get x equals 125. Now on F, you'll notice I have 2 logs. I can't solve 2 logs until I can set it equal to x. But to do that, I have to combine 2 logs down into 1. So we're going to use our properties. Remember, minus really means divide. So I'm going to do log base 2 of 112 divided by 7. So that is log base 2 of 16, and I'm going to set equal to x. Draw my hand. So it's 2 to the x equals 16. So 2 raised to what power gets me 16, and that is 4. Okay, if you need to rewrite this step or add this step in as saying 16 is really 2 to the 4th, you can. If you're comfortable, you can skip that part. So the last 3 questions. Plus really means times. So I'm going to do log base 12 of 9 times 16. So 9 times 16 is 144. Set equal to x and draw my hand. So that means 12 to what power gets me 144? X equals 2. Now H, you'll notice I have a big number 5 and a base of 5. Well, I know those are inverses of each other. Those are going to cancel each other out. but I can't cancel each other out until I get rid of all of this. I have to get it down to just 1 log. So to do that, first things first, any number out front is going to move back to its spot as an exponent. So this becomes 5 log base 5 of 2 to the third minus log base 5 of 4. I still have 2 logs. I need to get it down into 1. So minus really means divide. So I'm going to have log base 5. 2 to the third is 8 divided by 4. So that becomes 5 log 5 of 2. This cancels with this, so my answer is 2. Okay, last one. Just because we're dealing with logs doesn't mean I can throw my order of operations out the window. So I still have to do it from left to right. So first things first, this plus is going to mean times. So I have log 4 times 25. Now this minus is going to mean divide. So 4 times 25 is 100. So I get log of 100 divided by 1,000. Now I'm going to reduce, and I get 1/10. Notice this one doesn't have a base. Since it doesn't have a base, it is understood to be 10. So that's going to work out in our favor. So now I have log base 10. How can I rewrite this number as a base of 10? Well, it has an exponent, understood exponent of 1. And if I want to move it up to the numerator, I just change the sign. So that becomes 10 to the negative 1. Now these are the same. They undo each other. They cancel out. And my answer is simply negative 1. Okay, give your review problems a try today. Or give your problems a try today. It is the review worksheet. If you have questions, email me. And we will finish this lesson up tomorrow.